Systems of equations. Systems of equations is just a fancy way of labeling a set of two or more equations that share the same set of variables. Systems of equations are solved by combining the equations so that one of the variables cancels out. Let's take a look at an example. If 2x plus y equals 16 and x minus 2y equals 3, what is the value of y? So the way we'll tackle this is by stacking the two equations on top of each other. Instead of solving the two equations separately, because there are two variables, we'll use the two equations together. Always take note of which variable the question is asking you to solve for. In this case, it's y, meaning we'll want to get rid of the x's, and then isolate the y. So how do we get rid of the x's? Well, we'll need to get the opposite of x on the bottom equation. To do that, we'll multiply the entire bottom equation by -2. Distribute the -2 out, and we have -2x plus 4y equals -6. Don't forget to distribute to both sides of the equation. So now we'll stack the equations again, with 2x plus y equals 16 still on top and -2x plus 4y equals -6 now below it. Now we can add the equations together. As discussed, the x's now cross off. Y plus 4y equals 5y, and 16 plus -6 equals 10. Now simply divide each side by 5, and we have y equals 2. Another strategy for solving systems of equations is by using substitution. To do this, solve one of the equations for one variable and substitute for that variable in the second equation. Let's try it out. If 2x plus y equals 16 and x minus 2y equals 3, what is the value of y? Okay, so we have the same two equations from the last example, but instead of trying to cancel variables out, we'll isolate one of the variables. In this example, we'll isolate x by adding 2y to each side. That gives us x equals 2y plus 3. Now we can return to the first equation and plug in 2y plus 3 where x is. Distribute the 2 and you get 4y plus 6 plus y equals 16. Combine like terms and you have 5y plus 6 equals 16. Subtract 6 from each side and we have 5y equals 10. Divide each side by 5 and you get your answer, y equals 2. One of the decisions you'll have to make when it comes to systems of equations is choosing between solving with substitution or solving by combining the two equations you are given. The general rule of thumb is this: if a variable does not have a coefficient attached to it, then you should solve using substitution. If the variables do have coefficients in front of them, then you should solve with combination. Let's check out a practice problem. A store sells 20 lemonades for $64. Small lemonades are $3 and large lemonades are $5. How many large lemonades were sold? So let's break down the information we've been given. So let's have x equal small lemonades and y equal large lemonades. We know that 20 lemonades were sold total, so we can set up the equation x plus y equals 20. And we know that $64 total were earned. So we can also set up the equation 3x plus 5y equals 64. The question asks for how many large lemonades were sold, so we'll be solving for y. Let's solve by substitution by isolating the x. All we have to do is subtract y from both sides, and we're left with x equals 20 minus y. Now we'll take the 20 minus y and plug it in for x in the second equation. That gets us 3 times 20 minus y plus 5y equals 64. Distribute the 3 and we get 60 minus 3y plus 5y equals 64. Combine the like terms and you have 60 plus 2y equals 64. Subtract 60 from each side to get 2y equals 4. Divide both sides by 2 and we have our answer, y equals 2. Here is another example. If p and q are positive, p squared plus q squared equals 16, and p squared minus q squared equals 8. The q equals... This equation is already set up for us to combine the two equations, but we want to make sure that we isolate the q. Subtract the second equation from the first to get 2q squared equals 8. Dividing both sides by 2 gives you q squared equals 4. Finally, take the square root of both sides and you'll get q equals plus or minus 2. Therefore, our answer is 2.